Hey guys, it's Rob from BreVITy, and in this video, we are going to see the algorithm to solve a problem called the average of levels in a binary tree. So let's get started. So here we are on Leetcode, and the problem statement is as follows. Given a non-empty binary tree, return the average value of the nodes on each level in the form of an array. Now what do they mean by this? Let me demonstrate with the help of a pictorial representation. So here is a sample binary tree which I have taken. So now we can see that the first level consists of only one node, which is 2. So obviously the average of this level is going to be 2 by the number of nodes in that level, which is only 1 in this case. So 2 by 1 is going to give us 2. In the next level, we can see that there are two nodes, 7 and 5. So first we're going to add 7 plus 5, which gives us 12, and divide it by 2 because there are two nodes in this level. So over here we are going to get 6. In the next level, we are going to have 3 nodes, 2, 6 and 9. Here the number of nodes are 3. So we're going to divide 2 plus 6 plus 9, which is 17 by 3. So that gives us 5.67. Finally, in the final level, we have 5, 11 and 4. So now when we sum this all up, we get 5 plus 11 plus 4, which is 20. And then we divide by 3, which is the number of nodes in this level. So we're going to get 20 by 3, which is 6.67. So in the end, we're going to return this result array, which is going to be 2, 6, 5.67 and 6.67. So now that we have understood the problem statement, let us see the algorithm which we're going to use to solve this problem. So the algorithm which we are going to use is going to be the breadth first search, which is also known as level order traversal in a binary tree. So this is the step we are going to follow. First, we're going to create a queue to store the nodes as and when we encounter them. Now when it comes to breadth first search, we always are going to use a queue whether we're dealing with a tree or with a graph. So when you see the term BFS, you can instantly create a queue. The next thing we're going to do is create a result list to store the output. Over here, the result list was 2, 6, 5.6 and 6.7. So we need to store this so that we can return this as the answer in Leetcode. The next thing we're going to do is add the root node to the queue. We are going to apply BFS starting from the root node of the tree. So here is a representation of what we have done. So in the given binary tree, I'm assigning a letter to each of the nodes. So in this case, 2 is going to be called node A, B is for the value 7, and node C is for value 5, and so on. So I've created a queue and the result list below, and over here I'm inserting the root node into the queue, which is A in this case. Following this, we're going to initialize a loop which will run until the queue becomes empty. And we're going to declare a variable sum, which will keep adding the values of the nodes of a particular level as and when we encounter them. Next, we're going to declare a variable size, which indicates the current length of a queue. And finally, we'll initialize a for loop, which will run a certain number of times, which is going to correspond to the value of the variable size. So the reason this is very important is, how will we know when we have encountered all the nodes of a particular level? In order to calculate that, we are going to keep track of the number of nodes which are there in each level before we go into the for loop. And that is going to be denoted by the variable size in this case. Don't worry if you didn't understand that. It'll become more clear as we move into the visual demonstration of the problem. So here is what we have done so far. We have created a while loop which will run until the queue becomes empty. Inside this, we're going to declare a variable size which is going to point to the size of the queue. We are also declared a variable sum which will initially be 0. And then next we have declared a for loop which is going to run size number of times, and inside of this we're going to have some code. So what are we going to do inside the for loop? That is the next thing we're going to look at. Now inside the for loop, we are going to indicate the number of nodes which are contained in a particular level. So inside the loop we're going to do the following operations. We're going to first remove the first element from the queue, and we are going to call this temp. So whatever node which are pulled from queue will now be called temp. Next, we're going to add the value of this temp node to sum. Next, we're going to check the left node of temp, and if it is not null, we're going to add it to the queue. Similarly, we'll also check the right node of temp, and if it's not null, we're going to add it to the queue. So what are we doing here? For each node of a particular level, we are first going to add that value to the variable sum which we declared, and next we're going to check the left and right nodes of temp. And we're going to add this so that it will be checked in the next level while we run the next iteration of the while loop. When the loop reaches the final iteration, that is when I equals size minus 1, we have added all the values of a particular level to the sum. So now we're going to add the average value to the result list, which we can calculate using the formula sum by size. And finally, once we run all iterations of the while loop, we're going to return the result list as our final answer. So now let us do a dry run of the code. But before that, here is the overall algorithm of what we have defined so far. So on the left hand side, we can see the while loop, while queue is not empty, that was defined earlier. Now inside the for loop, I'm first going to poll a node from the queue. I'm going to add the value to sum. And next, if temp.left is not null, I'm going to add that to the queue. Similarly, if temp.right is not null, I'm adding it to the queue. And if the current value of I, which is the iteration variable of the for loop, reaches size minus 1, we are going to add this current value to the array list, which we have declared as result. So we are going to do result.add sum by size, which is going to add the average of that particular level. So now let us look at a dry run of the algorithm. So initially we have added A alone to the queue, and next we are going to poll A, and now we are going to add that value to sum as I've done over here. Earlier sum was 0, now I've removed A from the queue and I've added the value of 2 to sum. So next we are going to check the left value and the right value, and since A.left, right now temp is A, and A.left is pointing to B, which contains the value 7. So since it's not null, we are going to add it to the queue. Similarly, A.right is pointing to C, and since C is not null, we are going to add C to the queue. Now at this point, we can see that I is 0 and the size is 1. So I equals size minus 1. So when this condition is true, we're going to take sum divided by size and add it to our result list, which is what I've done over here. Sum by size equals 2. So 2 is now added to the result list. And now we'll move on to the next iteration of the while loop. So we're going to reset our values. So in this case, we can see that the size of the queue is 2. It has B and C, so the size is 2. And now we are going to poll B. So once we poll B, we are adding the value of B to sum. So sum becomes 7. So next we are checking the left hand side of B, and we can see that D is found. So we're going to add D to the queue. Similarly to the right hand side of B, E is found. So we are adding E to the queue. So the next thing we're going to do is increment I. So I now is 1. And currently we are going to poll C from the queue. So C is removed and the value of C is added to sum. So C is, so now we have sum as 7 plus 5, which is going to be 12. So now that that is done, we are finding out that I equals size minus 1 once again. So what are we going to do? First, we're going to check the right hand side of C, which is pointing to 9, F. So we are adding F also to the queue. After this, we're going to add the sum by size to the result array. So in this case, sum by size is 12 by 2, which is 6. So we're adding 6 to the result list. So now I'm sure you'd have gotten a gist of what the algorithm is. So I'm just going to speed run through the rest of the process. So next we're going to poll D from the queue, add the value of D to sum, check left and right hand side of D, it is null, so nothing is added to the queue. So next we're going to poll E from the queue, and when we poll E, we're adding the value of 6 to sum, so sum becomes 6 plus 2. And next we have to add G and H, which are the left and right hand side of E respectively. So once that is added, we can now poll F from this queue, and now it becomes 2 plus 6 plus 9, which is going to be 17. So we have finished yet another level, and again we're going to add sum by size, which is 17 by 3 in this case, and we're getting 5.67 as our next answer. So we're going to add that to the result list and once again begin the next iteration of the while loop. So in this case, we're going to poll G. So G has a value of 5, so 5 is added to sum. But the left hand side and right hand side of G doesn't point to anything, so if it's null, we are not going to add anything to the queue. Next, we're going to poll H, and we're going to add the value of 11 to sum. Finally, we'll poll I and add the value of 4 to sum. So sum becomes 20. So what is 20 by 3? 20 by 3 is 6.67. So 6.67 is the final answer that we'll be adding to our result list. So now when we do this, we will notice that the queue becomes empty. And when the queue becomes empty, that is the terminating condition of this algorithm. And when we reach this, we are going to directly return the result list as our answer. And that is what we'll do in this case, and that brings us to the end of this algorithm. So now that we have understood the algorithm, it is now time to solve the problem. As always, BreVITy will be solving this problem using all three of the programming languages: Java, C++ and Python. I'll be including them as part of the end credits. On that note, this is the end of the video. Hope you guys enjoyed it. If you liked the video, do like, comment and subscribe to the channel. This was Rob. You're watching BreVITy. Thank you and goodbye.